In any case, I think that now we can begin with our presentations. I was talking about variables. I see that one of the variables of today was not imaged. We have the first speaker who is not seen here. So we have to go to the second contribution, which is from Mr. Umberto D'Amato. Umberto D'Amato, I don't think, needs to be introduced because everybody knows him. In any case, he's a naval architect and he's a ship owner. He's the CEO of Perseveranza Navigazione and technical manager of the fleet. He's board of member of RAINA and a member also of several technical committees in Confiterm. But most important is the vice president of Athena. So, please, Umberto.
Okay, Alberto, thank you very much for your presentation, and thank you to all people coming here, especially for those coming to listen to me. In my presentation, I would like to talk about, first of all, eco-ships, pros and cons, so which are the advantages and disadvantages of a modern eco-ship. But the first thing I would like to point out, as many times I've been asked by people, is eco some additional class notation? Is something more than an ordinary design of a vessel is obliged to be done? I would say that it is not an additional class notation, but is an obligation nowadays that a new vessel, a new design must comply with a certain efficiency, energy efficiency design index. So, as Alberto said earlier, is starting from the model basing test till the final sea trials, a vessel must be certified that her consumption, therefore her emissions into the atmosphere, are below a certain level. So, we already told something about the bunker price, which has been increased dramatically. We can see in this graph, starting from year 2008, when there was the first, well, let's say earlier the market was rather high as for, well, the price of bunker was to the high side, above 500 tons, for instance. This is the prices in Rotterdam. Then going down dramatically immediately at the end of 2008 and going up, although the freight rates remains very low. And nowadays we are still in a very depressed freight rate market, talking about bulk carriers and tankers. But the price of the bunker remains still high. In this graph, you see the market value of a few days ago, 2nd of October, in the region of $540 per ton and above. As well, this other graph in Singapore, slightly higher, but again, the trend was always the same, a drop till 2008 and a continuous increase till reaching more or less a steady level about 500, 550 tons. So, what to do? Then comes the design of an eco-ship. So eco-ships means the word eco stands for ecological, economical, and electronic controlled. Maybe this was a former eco-ships, not so much on the electronic side, but next generation of electronic ships, electronic control will be maybe the one we see the model here. The eco-ships technologies available nowadays, we start from the ship design as a first. Then we go to propulsion, machinery, and then, of course, operation and maintenance is the paramount importance to keep the ship consumption and emissions below certain limits. When we talk about ship design, we have seen in the last few years new art forms, especially the after side of the vessel has been much more streamlined. As well, for fast vessel, we've seen new design of bulbous bows. As a whole, the main dimensions of the vessel, like length, breadth, CB stands for block coefficient, must be optimized. We have seen the introduction of new hull appendages, all aimed in reducing, of course, the power needed for a certain speed. As well, a lot has been achieved in the construction of lightweight ships, either with the use of high tensile steel materials or with the extensive use of tools like finite element methods in order to optimize the steel distribution of a hull. As well, the interaction between hull and propeller has been studied much more deeply in details. So the model basing tests have been carried out more and more frequently on a self-propelled model, instead of having separate tests for the hull under towing and then a separate test for the propeller. The combination is giving the best result. Well, hull smoothness, nothing much to say. Of course, you do not expect the hull of a ship to become fouled like in these conditions, but as well, even if there is no growth of barnacles, you expect the hull to be as smooth as possible in order to reduce at maximum the friction into the water. So we've seen the use of technologies like silicone-based paint, self-smoothing paints, but there are some cons about the use of those paints. First of all, especially the silicone-based paint, they have proven to be very highly effective on fast ships. Silicone paint cannot be applied at block stage during a ship construction, but at the end of construction, the ship may be put in dry dock again for applying the silicone paint. And even we have to consider that fouling can even grow when the ship remains idle in port or anchorage for long periods. I presume Dario Bocchetti later on will tell us much more about his experience about silicone paints. Then we come to propeller design. Basic principles for a propeller design are the larger, the slower, the better. I would add also the lowest number of blades, the better. But again, we cannot make largest possible propeller because there are geometric constraints. We can't exceed the ship's draft. We can't exceed 70% of the ship's draft. Which draft? We have to find an average draft between ballast and full loaded conditions. A propeller must be verified against the risk of running in cavitation. As well, this kind of propeller with large diameter, they receive also a high load on those blades. So in the end, we must reach a compromise for carrying out a proper design of a propeller for a specified vessel at a specified speed. That's very important, as Alberto has pointed out. We have seen in the last days a new design of propeller, like an advanced propeller blade section, propeller tips provided with winglets, like this one, which have been widely used for small vessels, but as in the last periods we have seen also large ships, large propellers provided with these winglets. As well, the propeller nozzle technology has been widely used already since a few years. And again, during the service of the vessel, the cleanliness must be kept at the best. A propeller like this, when the fouling of lime, of grass, of course, will lose its air efficiency. Therefore, it's necessary to carry out frequently underwater brushing, polishing of the propeller till reaching a roughness, so-called grade Rupert A, that means the highest grade. In this table, which used for comparison, the highest grade is here, like a mirror effect. Another possibility to keep the propeller always clean is to apply anti-fouling, like in those photos. But again, if something goes wrong, then you get detachments, like in this case, with the problem that in order to apply paint on a propeller, the surface of the propeller must be made rough. You can't apply any kind of paint on mirrors on a very smooth surface. So if the rugosity is increased by brushing or blasting, then if you have detachment, then you run in bigger problems. Then we come to main engine selection. Well, I'll just try to explain in a few simple words how is an engine selected. Once the model basing test has been carried out, so we are able to determine that we need a certain power. In this family of engines, we draw a horizontal line, for instance, for 15,000 brake horsepower. And then we cross this line with the number of revolution of the propeller. In this case, I've chosen 80 revolutions per minute. So the engine which is following one of those parallelograms represents a family of engines. The best engine, the one with lower consumption, is one which is optimized in this region, in the left low corner. So once we have found the engine, the family of engine to install on our ship, depending also on the dimensions of the volume available, then we come to optimization of this engine, to the choice of turbocharger in order to reach the lowest possible consumption. But as you can see in this graph, going a little bit above or below, then the consumption is increasing. So all the main engine nowadays are electronic control, to use an automotive term provided with common rail. And another interesting feature coming nowadays is a variable geometry turbocharger. Variable geometry you see in this image is a nozzle ring, which is a static part of the turbocharger, can be also varied depending on the engine load. But is a very modern technology, very expensive indeed. Then we come to the trim optimization. Maybe even the master of this vessel knew that changing a little bit the trim, he could achieve a much better consumption. So in those times, the master could only make a practical test and checking with the chief engineer the daily consumption. Nowadays, there are sensors and software able to give in any moment of the ship's trip the speed, the best trim for that draft in that moment. And then, okay, talking about hull appendages, the one which has gained the best success nowadays, the newest duct, is built by a German company, Baker Marine. I say just a few images of various kinds of ducts available. The purpose of the duct is to straighten, accelerate the hull wake into the propeller, producing a net head thrust, and also the fin system provided a pre-swirl to the ship wake, reducing losses in the propeller slipstream. Therefore, the both effects are giving, in the end, saving in power. I will tell about my personal experience as we have made on one of our ships, a Panamax bulk carrier and a post-Panamax, a retrofitting. The duct is provided into half, is fitted to the ship's stern, and this is the final result. This valve is also provided with another interesting item, which is the rudder bulb. So the result I can tell you about this vessel has been a fuel saving of about 5%, on top of reducing hull vibrations and gain a more stable revolution of the engine. More innovations are coming, all of them aim in saving consumption, saving money, and of course, giving a contribution to less emissions in the atmospheres. We have seen experiments for air lubrication. The flat bottom of the hull is built with a recess into which air bubbles are pumped. This is also giving a reduction in power. Counter-rotating propellers, we've been, for so many years, we have seen in outboard, small outboard engines. We see nowadays application also on ships as well, minimizing the resistance of hull openings through different design. We've seen also a combination of both rudder and propeller together. Another interesting feature which is coming nowadays is speed control of pumps, but not only of pumps, of any electric motor. All the electric motors and AC are running at one single speed. By use of inverters, the revolution can be changed, can be varied depending on the load. So, coming to the conclusion, pros and cons. Lower consumption, no doubt, means lower emissions, but a vessel is eco-speed optimized to a low speed. By changing the speed, either higher or lower, then the consumption changes, of course, but if a vessel has been optimized to a low speed, if the market changes and the vessel is requested to accelerate, to go faster, sorry, this cannot be done. The electronic engines nowadays, well, they are new generation engines, they look rather delicate like any kind of electronic equipment. My mobile phone, this PC, if it gets in trouble, then many times it's not even possible to repair. Those common rail technology means very high fuel oil pressure in the region of 1,000 bar and above. There is the need of skilled engineers. And then those engines are highly influenced on the quality of fuel oil. If the fuel supply is not the best with many elements like vanadium, sulfur, and so on, also the engine itself can suffer. Last is in case of emergency, an ordinary engine can be even running with one piston drawn out, not so possible for an electronic type engine. In this last slide, I just make some famous quote that when you make a list of pros and cons, some of those cons are what make many of the pros possible. Then, is everything always possible? Everything is theoretically impossible until it is done. As well, nothing is impossible, but depends on the money you have to spend. Thank you very much.
Thank you very much, Umberto. I must say, you said a sentence which is extremely true. It's quite simple. It's quite simple to slow down a ship. It's quite impossible